Hi everybody, we're back. It's another Mera tutorial, this time on management planning mode. I'm Tom Carruthers. So in this tutorial, we're going to assume you've already made an operating model, and what you want to do is test, in theory, the performance of alternative possible management procedures. When we say management procedures, we're talking about an interpretation of fishery data into management advice. So that could be a size limit. It could be a spatial closure. It could be a stock assessment that gives you, for example, a total allowable catch limit, something like that. So let's just have a quick look at the Mera schematic. Here we are on the Mera homepage again. If we go to the Help drop-down menu, we can open up the manual. Just zoom in. So in this manual, we go through each of the sections and provide you with advice on how to use all the features of Mera. For now, I'm just going to have a look at the introductory section and look at how to use Mera. And this provides us with a helpful schematic. In a previous tutorial, we talked about how to do this box at the top here, which was fill out the quantitative questionnaire. That had fishery questions, management questions, and data questions. Those together can be used to build an operating model. An operating model is a theoretical representation of your whole fishery management system, including population dynamics, fishery dynamics, data collection, and enforcement. Now, what we can do with that operating model is in the future, iteratively, we can use a management procedure, let's say a size limit, and then we can run it for a bit, take in new data and maybe adjust the size limit and so on. So we can, in the future, do a projection under a particular mode of management, a particular management procedure. That's this box here, management planning. We've done the questionnaire. We can now build an operating model, and we can use management planning mode to test, in theory, which MPs provide us with the kind of performance that we would like. We can identify knowledge gaps. We can work out which parts of our questionnaire are most important in determining the performance of that management procedure. And we can also work out what kinds of data have the greatest impact in our expected management performance. So today is all about management planning. In other tutorials, we're going to talk about management performance. So how well are we actually doing with our MP whilst it's in use? And we can also talk about status determination, which tells us what the stock status is. Today, right now, it's all about management planning. Let's go back to the app. Start by loading a case study that we've been working on. This is the one that we filled out the questionnaire for. Is tiger flathead in the southeast of Australia. Now, we've already done this questionnaire. That was in one of the previous tutorials. So you can always go back and see how we did that. Again, you can read the manual as well on guidance on how to fill that out. But once we've done that, we can choose a management planning mode. So we go to the options drop-down box, the menu up here, and we will select management planning. It's already been selected here. We scroll down below the questionnaire, we come to section 2. This is all about calculating that expected performance of some proposed management options. Now, for the purposes of this demonstration, we're just going to use the demonstration set of management procedures. Those can be selected here using the presets. So they come in the demo set. We can clear those. We can reselect them using demo. We can choose what's called top 20, which are 20 typical management procedures, and so on. When we select these, it highlights some named management procedures. The first one is a thing called depletion corrected average catch. Another one is a MAP len-lim. That's a minimum size limit at the age at 50% maturity. MR real closes the first area in our model to fishing. It's like a marine reserve. And real means it reallocates the effort to the open area. Remember, in our questionnaire, we did specify a spatial model with 2 areas. So this closing area 1. In current E75, we're using the current effort that's used in the fishery, but we're just using 75% of that into the future. And IT10 is an iterative index-based target approach. So what it does is it allows up to a 10% change in a TAC recommendation between management updates into the future. And it aims for a target index. Now, you don't have to remember what I just told you. You can just go up to the help section here, select the name of one of those. For example, I think we had Matt Lenlim. Let's go find it. We can select that and we can look at the documentation for it. And this opens a website on the OpenMSE website, which tells you all about what these size limit management procedures are and how they work. And it even provides you with code on exactly what they are. So we selected 5. They're the demo management procedures. They run reasonably quickly. What we do now is we just push calculate. So now what's happening is based on our questionnaire, it's built an operating model, Mera, and now it's running a planning analysis, which basically takes our operating model and does projections. Here you can see it working through the 5 management procedures that we've actually selected here. But it's not just going to do a management planning analysis, which is like an MSE, like a closed loop projection. For the operating model we've specified, it's going to do another one as well, which starts at a lower level of stock status. And that's a test to see whether it can rebuild. And so that's called the rebuilding analysis. So it's actually now done 2 MSEs based on these management procedures. One that follows the questionnaire exactly, the operating model, another the same operating model, but just starting at a lower level. A bit more in a second on how to specify that level for the rebuilding analysis. So let's have a look at our results, which sit below the calculate button. The first thing we have is a table 1, which is the projected biomass relative to what's called the limit reference point, LRP. The limit reference point is a biological reference point, and it's related to BMSY. That's the biomass that corresponds with maximum sustainable yield, a productive stock size. In this case, the limit is half of that, 50%. And this is telling us the probability that our management procedures will be above that level in future years. So here we have it over a reasonably short-term projection. And it's showing us that, for example, if we were to use DCAC, there's a 75% probability in this cell of it being above that limit reference point in 2022. And generally speaking, that is set to increase. That's not the case for all of them. Our index target approach, IT10, actually starts to decline near the end of that time period. So this is showing you different biological performance for these different management procedures. Now that's the limit reference point. For the target reference point, that's just BMSY. So this is a very similar metric, but it's based on a different biomass level. And in this case, you can see a similar pattern. It's actually a much smaller fraction in this case that is above. So these outcomes are actually quite narrow. So if we take a look at IT10, whilst it has a probability here of being of 2/3 in 2020 about being above the limit, it only has 25% probability of being above the target. So the outcome, the biomass outcome for IT10 is pretty squished in between BMSY and half of BMSY. If you look at one of these tables, it's going to tell you the type of MP it is. TAE is a total allowable effort MP. Remember that KER E75 is an effort control. It's 75% of current fishing effort. So for example, 75% of the number of days at sea. DCAC is a TAC, so a total allowable catch. Prescribes a catch limit across the fishery. We've got a size limit with Matt Lenlim, and we've also got an MPA class MP, which is this MR real, reallocates a closure, reallocates effort for a closure in area 1. So we've got these 2 tables that tell us over a short-term projection what's going to happen relative to our target and limit reference points. These tables are shiny data tables, so you can download them and copy them into other software like Excel. Here's a graphical representation of exactly what we just saw. Here we have a figure for each of the MPs And we can see on that the B relative to BMSY in the future. Remember, our target is 1. Let's see if we can zoom in here. Our target level is 1, and our limit reference point is 1/2 of BMSY. So those are those things there that's showing you those outcomes. And what we can see here is a projection of, in white, the median outcome, in the dark blue, the interquartile range, and then you've got the light blue area is the 90th interquartile range. So that's got 90% of the simulations in it, the light one, 50% in the dark blue, and then the median is the white line. The individual lines that you see plotted are 2 example simulations, giving you an idea of just how much individual simulations move around relative to these summary shaded areas. And so this gives you maybe a better intuition about what's going on in the future projections with respect to these various reference points, these various management procedures. So in the long-term HCR, the one thing I haven't mentioned to you at this point is that these projections are based on the base operating model. Figure 2 is based on the rebuilding analysis. So all of these start at 50% of BMSY. They actually start at the limit reference for biology. So they see what would have happened if we'd used these from a low level, which of these can rebuild and which cannot. And in this case, we can see very different rebuilding performance across the MPs. We've actually added an MP here called no fishing ref. So this gives you an idea for what would happen if you weren't fishing at all. So this MP is just to show you exactly how much the stock would rebuild and how quickly if we were to do 0 exploitation. But between the MPs, we can see very different future performance, with DCAC providing some near-term biomass rebuilding, whereas that is not the case for the current effort at 75%. The short-term HCR plot, figure 3, is exactly the same as figure 2, but just shows you over the first 10 years. So this is a prediction of the short-term outcomes of adopting one of these MPs. A pretty handy thing that Mera does is it will tell you the evaluation of current uncertainties. It will tell you of the questions you filled out in the questionnaire, which one had the most impact in the long-term yield. So for example, for the current effort 75, so for this MP, the most important question in determining yield outcomes at the end was fishery question 8, future catchability. In this question, across the range of uncertainty that we specified for that, this had the largest range of yield outcomes. So essentially what this is doing is it's taking this parameter in the model for future catchability, it's summarizing the simulations in bins across its range, and it's saying how variable is yield across the range of those bins. And that's what this result is here. So that's by far, maybe not surprisingly, since this is an effort control MP, catchability, which relates effort to fishing mortality rate, is the most important determinant of that, the success or failure in terms of long-term yield of this particular management procedure. For something like DCAC, it's much flatter, and there isn't any particular question which stands out. Although, for example, how well we report our catches, their bias, and the longevity of the stock span the range of how sensitive it is. So longevity is important across the range of uncertainty we specified, whereas the catch reporting bias is less important. Just zoom out again so we can go to a new plot. But the idea here is that you can focus in on which questions you need to spend most time on in determining. So for example, if you were to revise this questionnaire and you were going to use a current effort MP, you'd spend some time thinking about future catchability more than you would worry about the mixing of the stock. In this case, F18 future mixing really doesn't make any impact at all on this particular MP. So the spatial aspect of stock mixing across areas doesn't make any difference, whereas the future catchability does. This is the most important uncertainty in your questionnaire. Another thing it does, it looks at the types of data that go into each of these management procedures, if indeed they do use data, and it tells you, similarly to above, which of those data types or phenomenon affected this yield performance as well. So in this case, there's only one type of data source that goes into the MAT len lim. That's the length that maturity. So the only observation process bias that affects that maturity is the only thing that affects its particular performance. But you can see for index target 10, the level of index error was much more important, or somewhat more important, than the bias in that index. So this is pretty interesting, and it could help you worry whether you would be specifying or working on index that has greater precision versus an index which tracks biomass more closely. For example, for DCAC, its final performance was most strongly determined by catch error, then catch bias, then the bias in M. All these are inputs to DCAC. So this is telling you the value of information that goes into these MPs. And once again, the bars tell you how variable the yield performance was in the long term. Another plot we can produce is a yield projection. Clearly, we're going fishing. The objective is to harvest fish for food. So the purpose here of a yield projection is to understand what the trade-off is. So although some of these may perform well biologically, it's important that we present that with the context of what the yield outcomes are, the very purpose of this fishery endeavor. So these projections show you the same thing, but they show you yield relative to today. So you can have an idea of what the expected yield outcome is relative to today's yields. Similarly, we can plot the fishing mortality rate. In this case, it's the apical, or the most selected fishing mortality relative to FMSY. So this gives you an idea of whether you're overfishing, which would be Fs in excess of 1, or whether you're underfishing. And so in some management contexts, the likelihood of overfishing is an important metric for some management agencies. But finally, what we could do is we can plot the yield biomass trade-off. We want a situation where the probability of the yield is high relative to, say, 50% FMSY, and we want the biomass, in this case relative to half BMSY, to be high. We want lots of yield. We want to be up here. We want lots of yield, and we want lots of biomass. In this case, it's telling us, at least relative to half of BMSY and half of MSY, this relative yield is a sort of MSY. It's telling us that the current effort, 75, it wins in both. There actually isn't much of a trade-off, and this is both the highest in terms of yield outcomes and the highest in terms of biomass outcomes. It's a little more competitive in the space over the long run. So if we head back to our figure here, we can see that DCAC got us better biomass performance relative to BMSY at the cost of some yield relative to this 50% MSY. So when we phrase the x-axis in terms of BMSY, not half of BMSY, in terms of the target as opposed to the limit, there was a trade-off here. If we chose current effort 75, we could get better yield, but it would come at the cost of some reduced probability of being over BMSY. So this trade-off plot's a useful summary to give an idea of what we're giving away and what we're gaining amongst these various MPs. In this case, any situation where an MP is both lower in yield and biomass, for example, DCAC relative to current effort 75, we'd say it's dominated, and therefore there's actually no coherent reason, if we only care about these two metrics, to choose DCAC over current effort 75. It's outperformed in both of these axes. That's the case for Matt Lenlim and current effort 75. It's dominated in this plot and this plot. So based on these metrics, you'd always choose current effort 75 over Matt Lenlim. And that's the end of the results presentation for management planning. One thing we can show you just as we scroll down, and that we maybe haven't spoken about before, is that when you use Mera, it actually stores a log of all the things that are going on. So if you do find a bug or there's some kind of issue, you can always download this log and send it to me. That's tom@bluematterscience.com. And I can help you figure out what's going on and potentially fix the problem. One other thing to show you, which I think is relevant, is that now you've got this management planning mode, you can make a report. So we've run it, so it's gone blue now. We haven't done these other things, but management planning is available, so we can actually make an automatic Markdown report. It's like a PDF, which details all the outcomes you just saw. Sorry, it's actually an HTML. And here's that plot. It's exactly what you just saw, but this is that file. and shows you the same tables and the same projection plots, which you just saw inside the app, but now you have a permanent copy of that for your records. One thing we can come back to now that we've done a management planning mode is a few of the details around what you can do in terms of your setup of the model. So if we head over to settings here, we can see a few things that we can adjust when we do our MSE simulations. The first one's a plus group. Whenever you have a model with numbers at age in it, it's tracking fish in each cohort through the years. You've got the option of aggregating age classes above a certain age so that the calculations are simpler. You only do this in situations where you know that all the ages above this age have the same selectivity, the same maturity, and things like that. So for computational efficiency, you can specify that, and that can make the model run a bit quicker. By default, Mera goes to either the minimum of this 40, which is the default here, or whatever the survival, the age at survival to 10%. So where there's only 10% of individuals beyond that age class based on its natural survival. So it chooses something anyway for you, but you can actually manually change it here. You've got the option of changing the seed. So if you want different results, different stochastic results, you can actually specify a random seed. Just a note here that you have to choose integers, otherwise R just rounds down. So you can choose a random seed here if you want to get different results. Whenever it chooses parameters from the questionnaire, it actually defaults to a truncated normal distribution. In this case, let's say you had a minimum natural mortality rate of 0.2 and a maximum of 0.4. The truncation occurs at the 95% interquantile range for that particular parameter. And you can change this. If you want it to be a flatter distribution, for example, you could move this into, say, 50%, and that would happen at the central part of the normal distribution. Alternatively, you can just choose a uniform distribution, and it will be as likely to sample an M value all the way between 0.2 and 0.4. But the default is truncated normal, and it leaves off the 2.5% tails at either end. But you have the ability to change that if you'd like. Because we're doing a forward projection into the future and testing these management procedures, we have an assumed management interval. This is the number of years in between which you would set a new piece of management advice and then keep it for this interval. So every 4 years, the data are put together, a new management recommendation comes out, and that's what's simulated in that projection. You can reduce this all the way down to just 1 year if you want to do it every year, or you can bring it up as far as you want, and update your management every 10 years or something if you really want. One of the most important aspects of the simulation is to add lots of simulations if you want stable results, i.e. you don't want to be in a situation where if you just added a few more simulations, you get a radically different outcome. So control of simulations happens here. The default level is 64. That's reasonably quick, but it's not altogether that stable. The demo, which we used, was 24, which is very fast and suitable for this type of presentation. So if you just want to show someone Mera, use 24, for example. If you want really stable results, things that aren't going to change a lot, you probably want to make this in excess of 128, something like that. You'll notice that I'm using numbers which sound a lot like they round to or divisible by 8. That's because of the way that current processors work. So if you were to use 128 in here, you might want to turn on the ability to do parallel computation, which means that this job will be split up across the various processors on the server and it will run much faster. One option you've got, you remember that when we pushed calculate, it automatically built the operating model. You can just push this button and remake the operating model from the questionnaire right now. And that's useful because you can save that in the file menu. So if you just want the operating model without any of the other analyses, you can press make operating model and then download it from the file menu. And that means you can export it to OpenMSE and R and play around with it and then load it back in if you want. If you remember, we did 2 MSE projections, one for the operating model, which we specified with the questionnaire, but another one where it started at a low level, the rebuilding MSE. And that was used for those HCR, harvest control rule projection plots. And this is where you get to choose what that is. It defaults here to 50% of BMSY, but you can actually move this around and choose different ranges if you so wish. Something we'll come to later is the ability to load data and condition the operating model. If you want to do that, you click this button here, and there's a whole bunch of other options you've got down here for the type of conditioning model and other things. Now, we will come back to this operating model conditioning section when we come to status determination. So you'll just have to bear with me, but these are controls that alter the way that the model is fitted when you've added data. More on that later. And I might try and do another one on my fingers where I point, this is where you go for status determination mode. Hopefully I can add that as a timestamp beneath this video. Just a reminder that we do have these other modes I'm going to talk about. So we have management performance mode. That will be the next tutorial in the series. We have status determination mode where we add data, like I just said, and we do model conditioning. And that's going to give you an estimate of stock status. And it's also going to condition your operating model to be, let's say, empirically plausible based on the data that you've actually gathered. For now, that's it from me. I'm going to try this time to hang up quicker on you guys. But thanks for watching. And once again, any emails you want to send to me on bugs or things you want to have added to Mera, it's tom@bluematterscience.com. Thanks a lot, guys, and I'll catch you in the next tutorial.